So if you've been watching any of my most recent videos, you'll know I put a lovely little $29 Android Auto head unit holder on the top of my Pajero dashboard to replace the gauges and to make sure that people weren't looking down below the air conditioning controls just to control the radio, because the angle is really bad. But I figured, and I'm a big fan of this, having some steering wheel buttons to further reduce the need to touch the screen, particularly for my kids who are going to be new drivers soon. And I thought this would be just as simple as it might have been with my Evo 10 steering wheel installation on the good old Legnum VR4, where it would just be a simple resistor network. So I found this bad boy on eBay. It's a 2003 Verada steering wheel, including the buttons and the airbag, for a fairly decent price. So I figured that getting this other steering wheel from a Verada on the Pajero would be as simple as taking this style of wiring diagram that's used on the 2007 to 2000 I don't know, whatever, the Evo 10. It also includes the Lancer VRXs, where, you know, all these buttons on the steering wheel are just a resistor network. 1, 2, 3, 4, 5. In this case, 6, 7, 8 buttons, all one resistor network. Well, this is not what I wanted to see. It's a microcontroller in here, and you need to give it 12 volts, and when you press buttons, it either falsifies a resistor network or it is sending digital pulses. I didn't think the Verada was OBD. So I'm in the middle of, I'm diagnosing and mapping out the steering wheel controls for the Pajero. Bit of reflection there because the lamp's on and the light, and what wire does what and what the resistances are. I was getting some really weird data out of this, and I'm thinking, that's weird. Why is it doing that? But it turns out that the signal wire on here, if you look at the plugs, is shared with the signal wire coming out of the cruise control resistor network. So it's a shared signal. So basically, this is a terrible diagram, but basically let's see if I can do this. The cruise control gets plus 12 volt power into it from some source, which is ignition related. So if the ignition is on, it's on. If you press the cruise stalk, it grounds out it pulls this to ground. So that's an on-off signal to the cruise control unit, which is obviously providing this power. But if you use any of the stalk controls, there's 3 of them, up, down, and towards you, basically towards you like that, which is cancel, then it goes through the resistor network, and there'll be a voltage divider in the cruise unit, which is detecting that change in resistance by monitoring the voltage through a voltage divider. But I was looking at the wiring for the radio controls, right? The buttons which I'm trying to get working. And what's really weird was that the ACK wire, which is, if we look at this, it says ACK and SIG. If you can see that. SIG and ACK. Right, so accessory is white blue in this one, and SIG is white yellow. But this wire, this ACK wire, is tied to the blue wire, which is the blue wire coming from here as well. So this guy's ACK wire is tied to the SIG wire of that one, and this guy's SIG wire is going to black yellow. Now, the power is black-white for the cruise, and supposedly the signal for the radio is black-yellow. I don't think so. Someone's been in here before me. Look at all that flux. There's no flux on the factory stuff. Look at it. Right? This is like wave soldering or whatever that they've done. There's flux here. I think some numpty's been in here and wired this backwards. Because I wasn't getting power when I was applying to this pin, which, you know, made sense. And I went and looked at it. I'm like, oh, no, that's ACK. No, I think these are around the wrong way. Because I'm only getting power, and this thing does light up. There's LEDs in here, which... I need to zoom back out a little bit. There's LEDs in here, which light up behind the buttons whenever it has power. So, yeah, it was only lighting up when I was putting power to the wrong pin. And you can't provide plus 12 volts to the blue wire because the blue wire has no signal on it, right, until it's not supposed to have anything on it. That's just my thing timing out. The blue wire's not to have anything on it until you start, you know, flicking these buttons, right? So like when you do this, right, you'll create a circuit between plus 12 volt and out to the blue wire via the resistor network. So yeah, I'm gonna unsolder that and redo it. I mean, look at it here. It looks really brown, doesn't it? Who the fuck knows how long that happened? How long ago that happened? And I'm the poor schmo who happens to get it right when I'm trying to do a resistor network hook up to a Pajero. So here's a still shot of my oscilloscope connected to the buttons, and you'll note that on the oscilloscope it has what looks like pull down pulses from the peak of, in this case, obviously 12 volts. And so the pull down on this particular one says 412112, and that is effectively the code. So what I had to do here to get this to work with an Arduino was to get the pulse width timings assessed, and that's why the oscilloscope has these vertical dotted lines. You can see, I can see the entire signal duration. I can even align those bars to see the maximum duration of a pull down pulse, the gaps between numbers, and if you hold the button down, it also captures the gap between repeating codes. So using this, I was able to deduce what the actual codes are. So I'm going to press different buttons here. So I'm not sure if you'll notice the different patterns. It's hard to tell, actually. They're repeating. And because it is literally an IR remote controller chip in there that's doing it. So what I need to do now, if I want to use this system, and look, it has cost me a couple $100 to get a steering wheel and this and everything and whatever. I'm in now. So all I have to do now is build a microcontroller chip which intercepts these pull downs and translates those to a resistor network, because what I noticed on here is, I'm sorry about the camera work, I've got to look at what I'm doing. When I say learn something, right, see it says volume up, volume down. If I press volume up now, it's going to clear out volume down, because this system in Kenwood does not know how to read pull down pulses. It only knows how to read resistor networks. I'm not sure why it has 3 wires. All I know is when I measured them, this one here was like 3 volts output, and the green one is 3.3 volts output. And when I tried to use this one with the pull down method on here, it didn't register anything at all. So yeah. So here is the solution to emulating a resistor network using an Arduino. It's a digital potentiometer. This one's just from JCar. There's probably better examples, but this is what I had access to, and it does actually work, as you'll find at the end of the video. So basically we read the serial pulses in the Arduino from the buttons being pressed, and then we connect the digital potentiometer to the wires on the Kenwood head unit to simulate a resistor network, because there's enough steps in this digital potentiometer to provide a differing resistance gap for the Kenwood head unit to work. Okay, for those of you who are not massive nerds, this is going to bake your noodle. And you can skip this completely and just go to the look it's working part of the video. But here's the Arduino code. This is also available in the GitHub repo. But let me walk through what this code does. So number one, we include a third-party library for using and interfacing with an MCP 4151 digital potentiometer. And basically this is just the serial communication set up for talking to that chip. It uses the SPI protocol. So then what we do is we configure the Arduino to have a pin dedicated to detecting the pulse signal, and then we have settings related to detecting what the pulse values are in microseconds. So it's saying if it's at least 460 and at most 520, it's a pulse. And then it tells you what the minimum maximum gap is between pulses and the maximum duration at the end of a number. So like a 4, 1, 1, 2, the gap between the 4 and the 1 would be 1900 milliseconds at most. And then there's 10,000 milliseconds between when the entire cycle repeats. And then when the button is pressed, the Arduino uses this to capture that number and iterate through an array. Anyway, here is the sequence mapping. So there's only 6 buttons. And why did they choose a NEC specific infrared remote chip, and rather than using the remote output pin that has a carrier signal, why did they use one of the button matrix output pins? I don't know. It seems massively over-engineered, which I suppose is typical for Japan in the 90s and early 2000s. But basically, if you press the change button, it sends out the code 43112, and I think you saw 412112 in the example earlier. These are the codes. So basically, it reads the codes, and then it looks them up against the table and it knows, oh, you've pressed this button, and then it decides what to do based on the fact that you've pressed that button. So the loop effectively runs through and says, look, as long as the button's being pressed, and it does this by looking at the timing of the signals it's receiving, and you've actually calculated a value, like you've determined what button is pressed, then what it does is it goes and tells the MCP 4151 digital potentiometer to output to select a specific potentiometer position. And here's that code here. So it says set resistance for the sequence, and the sequence is the number, right? The 412112. So it says if the number was determined to be the change button, then set the hex value, or the 0 to 255 value of the potentiometer to 55. I'm not exactly sure what the resistance is of that particular position. There'll be a lookup table in the data sheet for the MCP 4151, but I know it works. And so then what I had to do was provide a big enough gap between each button that the resistance would change enough that the Kenwood head unit was able to detect that change in resistance. And if it can't work it out, it just writes 0. And what that means is it goes to one extreme edge of the potentiometer as if no button has been pressed, because that's the default when the potentiometer boots up. It boots up to, actually I think it boots up to the middle. It boots up to the middle position, which is like 128. But actually at the beginning of the Arduino code, I say, no. At boot time, I want you to go to 0. I want you to be just sending the full signal, no resistance, out to the, through the potentiometer. But yeah, so if it can't work out what's been pressed, it'll just say do 0. It's the safest option. So there's a function here which translates the received sequence into the numbers, and then it actually goes and applies that to the value. So if you look at the the actual loop of the code, you'll actually see it doing that. And that's done here with this print sequence, reset sequence. It's currently called print because I was using serial output. I could rename that. But if you go and look at print sequence, it goes and does the translation, sets the resistance, and which is obviously outputting the value to the potentiometer, and it's also spitting code out to the serial port here of a button has been pressed. Handy for debugging. This will probably be removed in the production code if I haven't already removed it in the GitHub repo. But you can see it's fairly simple. All I could say, if you really want to try and work out how this actually operates, is go to the GitHub repo and read the code and sort of visualize and step through the code to see how the thing is actually working. I will admit I had to lean heavily on ChatGPT here, as I don't really have any experience prior to this in microsecond timing of reading digital serial pull-down pulses on an Arduino. So this is effectively done. It's not fully wired in yet, but we've got the Arduino with the MP4151 digital potentiometer that is wired into, bizarrely, the steering input and steering input 1 lines, not using the ground or that one. I accidentally did this and it worked when I was having issues with the other setup, so I'm not really sure why it's working across these two when these both have positive voltage on them. Last I checked, but hey, it works. These two run through the inner and outer terminals of that MP4151, and I've got a wheel I got was absolutely manky. It was stuffed, but for $37 I got another Mitsubishi Verada wheel. You'd call it a Diamante in America. I think it was a 1999 model. They are both airbag cars, so I will have an airbag here which is inert because it won't have any power provided to it. That's the best I could do for the prices I wanted to look at and the fact that they fit the existing splines. Anyway, so we got the new cruise stalk. That'll have to be wired in custom. I'll have to replace the resistors because the resistor network here is different to the resistances of the resistance that the cruise in the Pajero wants to see. The power button, I'll have to probably run through the Arduino on another pin because this is the power for the cruise here, and that's off. So that's on, that's off. I'm not really sure how this is working because when you turn it on, it actually lights up this LED here. So I'll work it out. It's nothing. But because this is all grounded already, the only thing I have to worry about was taking my replacement Deutsch connector off the back of the clock spring here and just wire power in for now. It's already grounded because it's grounded through the steering column itself. That's the ground for this, for the whole steering wheel, which is why the horn will work. Well, apparently the horn doesn't work when it's only on accessory. I thought it did, but it does. Okay, why is the horn not working now? It was working. Oh, that's because I've unplugged that connector. There, the power for the the power for the horn isn't hooked up. Okay, anyway, so yes, it's working. That's a 10K pot in the 4151, which actually works out to be good because I had a very low value, like the pot's got 8-bit steps, so I had a value of 30 for this button here. And it wasn't actually... I've just pressed cancel. It didn't want to listen to me. That, by the way, is currently mapped to the voice button. Yeah, so I think I had it in the end. It was like not a PWM value, a pot value of like starting at 55, then 80, then 120, then like 160, then like 190, and then like 220 or something, and that works really well. So the resistance created from those settings is excellent. I will obviously share the code in the repo, but yeah, you can see volume going up. So if I can get both in, volume down, I can skip forward. Yep, skip back, and mode just changes the device which it's using. Now, here's what's really good. Note, interestingly, that this steering wheel control has secondary functions here. Now, holding these buttons down doesn't actually do anything in this unit. As we know, this is an IR controller in here. It still sends the same pulses whether you tap it or hold it. But what I can do in my Arduino is say, if it's a tap, right, then do forward. And if it's a hold, then do voice. Or this says scan, but yeah, whatever we wanted to use it for. So this is the benefit of digital control. As long as you're in the line, you're in between the sender and the receiver of a signal, you can decide what the actual behavior is. I could, for example, say if you press this 3 times, then it would do a specific thing. Yeah, it's excellent. Yes, so the only thing to do now is what I have to do is take... So what's interesting about the way that this wheel works is the button signal, which is a pulse pull down, and the cruise control, which is a resistor network, are the same signal wire. And I've got videos, I think, or I can prove it by probing these out. These are connected. So what I'm going to have to do, and I stupidly cut these a bit short, but these are the wires that were for the airbag. So what I'm going to do is I'm going to cut and splice this guy, which plugs into the cruise unit there, into those wires. And on the back side of this, on the wheel side, on the steering column side, sorry, I will also take these and make them the wires for the cruise unit, so that the cruise and stereo controls are on totally separate circuits, because I don't think that having the cruise connected to that's going to work. And the reason I say that is that I am providing like the signal pull up, right? So I think the 5 volt or 3 volt line pull up is provided by the cruise unit, but it's just 5 volts or whatever it is on that wire, and when you press these buttons, the pulses pull that wire down. But if I plug in, the way my Arduino is working is it's doing an input pull-up, right? So it's providing the 5 volt. Having said that, I suppose I could change my code in the Arduino so that rather than being an input pull-up on pin 2, it's just an input, and it sees the 5 volts from the cruise unit and it's pulled down. That might actually work. All right, next part of the project. Righto, folks, it's actually sometime later. I've been driving the car for a while. Everything's working great, except I do have a couple of issues where occasionally when I'll turn the indicators on and everything, it will actually trip one of the buttons. Now, it's not the digital stuff. I think what it is the fact that the ground wire on the steering remote in the back of the Kenwood isn't connected to the other side of the digital potentiometer. I think maybe so it's a floating voltage issue, so I need to solve that, but it's 99% great. So if you do happen to just try and follow along with this and you're wondering why it's a bit weird, that could be what it is. Okay, just cutting to one of my pictures here of the setup. I forgot to mention that the steering wheel assembly I ordered also needed the clock spring from the Verada, and I will tell you that the Verada clock spring is a direct drop-in for the Pajero clock spring. Basically, obviously, you need to do the wiring on either side of it to connect to your car, and I'm using Deutsch connectors, but it's a complete straight drop-in. The other thing though I did is I did not replace the cruise control stalk at the current time. What I discovered is that the old cruise control stalk for the non-airbag wheel has the exact same mounting holes. So what I've just done is I've got the signal wire for the cruise stalk connected to the old unused inert airbag wires, and that's connected up to the old wiring for the old cruise system for this car. And the button wire, signal wires, on their own dedicated circuit. I just ran out of time. I wanted to get the video done, and it's one of those things where I'm sure I could work it out, but I haven't bothered, and I've got other videos I need to release, particularly the one on the UT comp for this car, which basically has things like oil pressure and engine temperature and fuel consumption for the LPG and the petrol. Next video. Okay, but I wanted to make sure I got this one done. So yes, it is working excellently. I would show you again, but I think we have to wait for the thing to boot up. Just hold on. So we're back. Yep, so here's my volume buttons. You can see them working. You got, if I flick through the radio stations, you'll see that working. That's these buttons here. Change is my source. As you can see that working, and mode is currently my voice button. So the issue I'm actually having, I mentioned just earlier, is sometimes when I'm just like turning the indicators on or whatever, that electrical noise in the system will cause the Kenwood to think that a button's been pressed, because all it has to take is for that voltage to fluctuate to a point where it would be considered one of the valid signals. And the way it works is in the configuration under user interface and steering buttons, we've programmed these, and they're programmed based on a scene voltage. So if that voltage is wavering and floating, as opposed to being fully up, fully down, or when I drive it, then of course that could be an issue, and that's the issue I'm going to actually work out. I will provide an update when I do that. But fundamentally, this is working great. Hopefully, if you want to do this, you can follow my GitHub repo. I'll even have schematics for the Arduino circuit board that I created. And yeah, good luck.